Hello everyone, welcome back to Quotas Management. So in today's video, we are starting a completely new playlist on Agentic AI engineering. So if you are a software engineer or Java developer, Python developer, cloud engineer, data engineer, or someone preparing for AI engineering interviews, so this playlist is going to be very important for you. And we are not gonna start directly with any framework like LangChain or LangGraph, MCP, or any other framework. We will start from very fundamental thing and we will proceed step by step. Because before learning how to build an AI agent, we need to understand like what exactly is an AI agent, what makes an application agentic, why is not ChatGPT by itself necessarily an agent, what is the role of an LLM, what are the tools, what is memory, what is state, and most importantly, how does an AI agent actually make decisions and perform the actions. So by the end of this episode, you should have a very clear mental model of agentic AI. So first of all, we will start with a very realistic problem or real world example, you can say. So imagine I tell an AI system that like find the cheapest flight from Kolkata to Bangalore next Friday and check my calendar and book it if I am free. So now let's think about what needs to happen. First, the system needs to understand what I want actually. Then it needs to search for flights. It needs to compare the prices. It needs to understand what next Friday means. It needs to check my calendar. Then it needs to determine whether I am available. So if I am available, it may need to book the flight. And finally, it needs to give me confirmation as well. So the process could look something like this flow. It will understand the request. Like first of all, user will request, and after that, the model actually understand the request, then check the calendar, then search flight systems, compare the prices, check the constraints, make a decision, ask for approval if required, book a flight, and confirm booking. So core idea is agentic AI is not simply about generating text. It is about working toward a goal by deciding what actions to take. So it is performing a task. It is deciding what should I do next. And that is where the concept of agentic AI comes in. So before understanding agentic AI, we need to understand how AI systems have evolved. And according to that, I have divided it into like three stages. First stage is traditional AI, second stage is generative AI, third stage is agentic AI. So what this traditional AI is? So traditional AI systems often focus on prediction, classification, recommendation, or optimization. For example, like suppose we have customer data. We want to predict whether a customer is going to leave our service. So we give the data to a machine learning model, and the model produces something like it will give the customer ID, suppose 1001, and the churn probability. Suppose churn probability is 82%. So if you know about what is the churn, then you can comment below. So the flow is like input, then machine learning model, and after that prediction. So the model performs a specific task. It does not necessarily decide what the next business action should be. Next is generative AI. So generative AI became extremely popular because models such as like large language models can generate new content. So for example, I can ask like write a Spring Boot REST API for creating a customer. So the model can generate the Java code, or I can ask like explain the microservice, and it can generate an explanation of the microservice. Or I can say like summarize this document. So it can summarize the document as well. So the basic flow is user will give the prompt. then large language model, and it will provide some response. So these are some examples what I have told you. So this is extremely powerful. But there is also a limitation. Suppose I ask like create a Spring Boot application, compile it, run the test, fix any errors, and create a pull request as well. So a normal LLM response might generate the code, but generating code is not the same thing as actually performing all the operations what I have requested. So it would need access to a file system, a compiler, a test environment, Git, GitHub, or any another source control platform, and possibly CI/CD. So it would also need to decide what to do based on the results. And that brings us to agentic AI. So that's why the next part, as of now, the ultimate part is agentic AI. Maybe in the future, some another phase will come up. So agentic AI adds something very important, like the goal-oriented decision making and action, not only decision making. According to the decision, it will do the task as well. So it completes its action. So instead of simply like through prompting and getting the response, we can have like a proper goal, then reason, plan, act, observe, reason again, continue or finish. So the key difference is like generative AI primarily generates an answer, but agentic AI works toward a goal. So that is one of the most important lines to remember from this entire playlist. So let me repeat it. Generative AI generates an answer, agentic AI works toward a goal. Correct? Now we will know about what is an AI agent. So what exactly is an AI agent? So a practical definition is like an AI agent is a software system that uses an AI model to reason about a goal, decide what actions to take, interact with tools or external systems, observe the results, and continue until the task is completed or requires human intervention. So let's break that definition down. Like there are several important components. First, I have told goal. So what are we trying to accomplish? That is the goal. Second is reasoning. So that means what should happen next. Third is planning. So how can the goal be like broken into steps? Fourth is tools. So what external capabilities are available? Next is state and memory, like what has happened so far. Next, action. What should the system actually execute? Seven is observation, like what happened after the action. So these components together create the foundation of an agentic system. Next is the LLM is not the agent. So now let's discuss a very common interview question like is an LLM an AI agent? So the simple answer is not necessarily. An LLM can be the reasoning engine of an AI agent. So think about a human being. Our brain can make decisions, but our brain alone cannot perform an external operation without some physical capability, right? So similarly, an LLM can reason and generate some decisions, but an agent needs additional components to actually interact with the outside world. So think about the architecture like this. I have kept the LLM reasoning engine, like LLM, what is the reasoning engine, and other parts like tools, memory, state, planning, control logic, some guardrails. So in these two parts, I have divided the AI agent. So the LLM is a major component, but the agent is the complete system. So this distinction becomes like extremely important when we start designing enterprise AI systems. Now we will know about what are the tools, like components of an AI agent. So an LLM by itself has limited ability to interact with external systems. So tools basically give the agent additional capabilities. For example, database, REST API, web search, calculator, file system, email, calendar, CRM, payment systems, code executions. So first of all, see the if we will consider the components, there are several components. First one is suppose model, then tools, memory, state. So model can understand the intent, reason about a task, select tools, generate structured decisions, and analyze tool results. After that, these are the tools. So suppose the user asks like, what is the current balance of my account? So the LLM may not know the current balance, but it can use a banking tool. For example, we can create some method that get account balance. There we can write our business logics. So the tool could communicate with a backend service and the backend will return the balance. So the agent then uses the information to construct the response. So the from the user, it will go to the agent, then to LLM, then it will select the tool. Like I'm just assuming the flow. So suppose user, from user to agent, agent to LLM, LLM to select tool, then it will call some banking API. Banking API will give you the result. Again, agent can interfere, and then the agent will give you the response. Then memory. So the next component is memory. So imagine I tell an AI like my preferred programming language is Java. So later I ask like what programming language do I prefer? The system needs some mechanism to retain that information, right? So this is where memory comes in. So at a high level, we can think about two categories. One is like short-term memory, another is long-term memory. So short-term memory, basically this represents the current conversation or task. For example, like my order number is 12345. So agent will give me okay, and uh, again I can ask like where is it now, right? So the agent needs the order number from the current context. And long-term memory is the which means it can persist useful information beyond the current conversation. For example, suppose user preferences, previous interactions, important facts, historical context. So later in the playlist, we will discuss like how memory can be implemented using databases, vector stores, checkpoints, and other mechanisms. For now, remember memory allows an agentic systems to retain useful information across interactions or tasks. That is the long-term memory. Next is state. So now let's discuss something related but different. Like state, that is basically suppose we are processing an order. So the current task might have this state. There will be customer verified, suppose true, order found or not, payment status, shipment status, refund required. So these information represents where we currently are in that workflow. The agent can use this state to decide what happens next. For example, if the shipment is delayed, perhaps we need to check the refund policy. If the payment has not been completed, maybe we should not proceed with shipment. So, like state is essentially the current context of the ongoing task. So this concept becomes extremely important when we later learn LangGraph. Okay. So as of now, you know these are the components that model, tools, memory, state, right? These are the components of AI agent. After that, the agent loop. So now we are coming to one of the most important concepts in agentic AI, the agent loop. So let's imagine the following process. Goal, then observe, the reason, plan, act, observe. We will check task is completed or not. If no, then continue. If yes, then finish. So the agent does not necessarily know the complete path in advance. So it can make a decision based on the result of the previous action. For example, suppose we are asking to an agent like find information about a company. Then agent will give us like I need external information. So the action will be like search results, whatever received. Like first of all, like the action can be like search the web. And what can be the observation? Observation can be like search results received. Then agent will do like I need more information. Again, another action will be done like open relevant sources. And from that, again, another observation will come up like information received. After that, agent will do like now I can summarize. So, like after that, it will generate the response by the action. So this repeated process is what makes agents powerful. Like repeatedly from user to agent, then some action, then some observation, again agent, again action, again observation, like that. So that will be the flow, and that you can think as the agentic loop. Okay. So next is worked example, like customer sales. So customer support example, like that. So I have actually worked on this scenario, like on top of customer sales data. So let's take another example, like suppose a customer says my order has not arrived. So can you check what is happening? So a traditional chatbot might say, please contact customer support. But an agent could potentially perform several actions. Like the flow can be like from the customer, it will go to the support agent. It will find the customer, it will find the order, then check the shipment, it will analyze the status, it will check the policy, and it will take the appropriate action, and finally we'll get the response. So the agent might have access to the customer database, order API, tracking API, refund API, knowledge base, and we get the, suppose the agent discovers the order, payment, shipment, delays. Okay. So the thing is, it will understand the goal. Suppose for that example, like find the total sales for customer ABC from last month. So it will understand the goal first, like calculate the sales for customer ABC during the previous month. Then it will determine the required capability. The database access is needed for that, right? Next, select the appropriate tool. For example, a customer sales database tool. Then execute the tool call. Then observe the result. Then validate or like interpret the result and generate the final response. Like get customer sales. Here, like customer ABC period previous month, and uh, it will give the result like orders as 37 total. How much sales has been happened, that one. So the agent can then respond like customer ABC generated 4,85,000 in sales from 37 orders last month. Okay. So the agent can reason about like what should happen next. Maybe the policy says that after 5 days of delay, the customer qualifies for a refund. Like what example I was giving, that my order has not arrived. Can you check what is happening? So for that, like it can think, it can through the API access and database access, it will fetch the details, and it can give me the proper response. So the agent can potentially initiate the appropriate process. So just think about that, that the agent directly is not just answering a questions, it is working toward resolution. So it is not like that. Suppose how much delay it can be, that response already we have fed to the model and model is giving us the answer. It's not like that. It's properly working, like how it can face the data, and from whom or from which system it can face the data. So proper working actually the agent is doing. Okay, so that example also have told you that customer sells like uh, whatever um, whatever like find the total sales for the customer ABC from the last month, that I have also given. And suppose how much delay I have not received my product, so how much delay it can be. So two examples actually I have given to you, right? So next we will know about agentic AI versus chatbot. So now let's compare a chatbot and an agent. So a chatbot is primarily designed around conversation, but an agent is designed around task completion. So for example, if you will ask a question to chatbot, then it will go to LLM and it will go give us the answer. But for agent, the if user will ask something, so it will identify the goal first, then agent will like do the reasoning, then it will select proper tool, execute that, observe that, if required reason again, and do the proper actions, and after that we will get the proper response. So a chatbot might say like your order is delayed, but an agent could potentially check the order, check the shipment, check the delay, check policy, create the refund, notify the customer. So the agent has an action oriented workflow, right? Now we will know about like agentic AI versus traditional automation. So now let's discuss another important distinction, that traditional automation is usually deterministic. So like if payment successful, send confirmation email and end. So the developer explicitly defines the condition and action through the proper programming with some set of rules. We have completed the programming, and according to that the traditional automation actually work. But agentic system is like it will identify the goal, understand the situation, determine the next action, use proper tool, observe result, determine next action. So an agentic system can dynamically select actions based on the current goal, available tools, state, and observations. So in production, this autonomy must still be constrained by permissions, validations, guardrails, monitoring, and approval policies. So the like for traditional automation, what I have told, like the developer explicitly defines the condition, action, workflow. So this is predictable and useful. But agentic systems introduce more dynamic decision making. So the agent can choose between multiple possible actions depending on the current situation. However, there is an important point, like agentic uh, does not mean uncontrolled. So in production systems, we need proper permissions, validations, guardrails, monitoring, audit logs, rate limits, this approval policies like human approval or like that, security control. So we don't want an agent to have unlimited authority, right? We need to review those things, whatever agent will do. Now, deterministic workflow versus agent. So let's visualize this. Like a traditional workflow might look like this A, after that B, after that C, after that D. But an agentic workflow might look like, suppose goal, then agent will find proper tools like tool A, tool B, tool C. Then it gives the result. Then agent will perform the next action. So the agent may select tool A or tool B or tool C, or if tool A, tool B, tool C, all are required, or any permutations, combinations, anything. So the result can determine what happens next. So this is one reason why frameworks such as LangGraph become useful for more complex workflows. But we are not going to jump there yet. First, we need to understand the underlying architecture. Now we will know about single agent architecture. So a basic agent architecture might look like this, like suppose user, then it will go to AI agent, then to LLM, and it will search for tool. some DB API tool or calculator tool like that. So the user provides a goal. The agent uses the LLM for reasoning. LLM is just like our brain. So the agent has access to tools. The agent decides which tool is appropriate, the tool executes, and the result comes back. So and the in this way the agent continues. So this is the basic architecture we will build on throughout this playlist. Okay. So next is multi-agent architecture. So now imagine that one agent is not enough. Suppose we are building an AI software engineering system. So instead of one giant agent doing everything, we could have specialized agents. Just like you can think about the monolithic versus microservice, right? Like why microservice introduced? Like in monolithic, like all the service logics combined in one uh, folder or like that. You can think that in micro like monolithic. But in microservice, what we have done? We have segregated the proper task to each service. Suppose for payment, payment service, for order, order service, like that. But in the monolithic, that type of segregations we have not done. So in the same way, in the single agent architecture, single one agent was only there to do all those tasks. But here for multi-agent, we have segregated. Like suppose user, then supervisor, then research agent do the research, then coding agent do the coding, like do the coding. Then data agent will prepare the data modeling or prepare the uh, proper like database management part and like data processing, data collections, like that. So the combinations of all, we will get the final thing. We can consider that as final agent, and the response will go to the agent. So research agent here specifically responsible for understanding the requirement. Coding agent here responsible for generating or modifying the code. Testing agent can be there, which is responsible for writing and executing tests. Also there can be review agent, so it can be like responsible for like reviewing the implementations. So this is called a multi-agent architecture. So we will cover this much later, right? So next, some real world agentic AI use cases. So let's look at some practical applications like software engineering agent. So imagine like first requirement understanding, then planning, coding, testing, review. For customer support, like customer support agent, knowledge base or order API, then resolution. Then data analysis, questions, then data agent, SQL tool, database. After that analysis, then it will generate the report. For research agent, like it will ask the question, planning, search, retrieval, analysis, validation, and report. So this is very interesting area for software engineers or the for the data analysis, data analyst agent. Okay, so in that way it actually work. So after that I will discuss about high level agentic AI architecture. So like in a production enterprise system we could uh, see like this architecture. So user will go to the AI agent, what I have asked, like what I have told you, like it will first understand the goal, then it will do the plan, do the reasoning and decision making. After that it will go to the LLM, then from LLM it will search for tools. So there may be some APIs or DB search, and through the APIs or something it will interact with the external world. And we have also the memory part. So another component. So it like whatever data, so like short term memory or long term memory, that can be stored in the vector DB history. Then state, that is basically the task context workflow data. So here also involves like security, observability, evaluation, some guardrails, authentication, authorization, logging, monitoring, all are involved in this part, right? So you can think this as high-level agentic AI architecture. Okay. So next, we will understand like the evolution of AI systems. So let's summarize the evolution. Like first of all, I have told you that the traditional AI, like I will give the input and it will give the prediction. Next is generative AI. So through our prompt, we give something and it will generate some content like any text or picture or video like that. Next is AI agent. So it will understand the goal, then reasoning, tools, some set of actions, then not a single agent. Also, we have discussed about the multi agent system as well, like multiple specialized agent, like research agent, develop agent, like coding agent, testing agent, DevOps agent. So multiple specialized agents actually do the collaboration and orchestration, and we will get the final results. Okay. So in that way, like the transformation happens actually. The traditional AI, then the generative AI, AI assistant, then AI agent, multiple agent systems. Okay. So next, now let me show you where we are going. So we are going to start from a simple LLM. So then we will learn like the tool calling, basic agent, memory, RAG agent, LangChain agent, LangGraph agent, MCP agent, multi-agent system, production agent, enterprise agentic AI. So this playlist is not going to be just how to use LangGraph. So instead, the objective is like to understand agentic AI engineering. Frameworks are just tools, but we will understand the architecture and proper engineering principles. So understanding the engine architecture and engineering principles, those are very much important. Next, I can give you some tips. That is so before ending the episode, so let's quickly cover some questions that can be asked in interviews. Like, what is Agentic AI? So agentic AI basically refers to AI systems that can work toward a goal by reasoning about tasks, selecting actions, using tools, observing results, and continuing through a workflow until the task is completed or human intervention is required. Now, the next question can be is an LLM an AI agent or not? So not by itself. So an LLM, I have told you that LLM you can think as only the brain, so it can decide something. It can help to do some decision making, but suppose through our brain we cannot complete all the task. Our brain actually decides some things, it makes some decisions, and through our hands, legs, and some other things, we actually interact with the external world. So here also the LLM only cannot do. The LLM can decide something, and the agent actually interact with the external world through some APIs or some tools. There is memory, there is some other states like that. So there are through the control logic, executions, and proper guardrails are also there. Right. Next, what is the difference between generative AI and agentic AI is the important question. So I'm just telling you, generative AI mainly focuses primarily to generate some content or response, while agentic AI basically focusing on achieving goals throughout, by reasoning, decision making, and tool usage. Then we have discussed about the agentic loop, and we have discussed some worked examples like customer cells. Then we have discussed about the difference between agentic AI and chatbot, agentic AI versus traditional automation, deterministic workflow versus agent, single agent architecture, multiple agent architecture, real world agentic AI use cases, high level agentic AI architecture, the evolution of AI systems, where actually this playlist is going. So that actually I have discussed, right? So the final point I can say that uh, so let's end today's episode with three things. First, the LLM is not the entire agent. So it is generally the reasoning engine inside the agentic system, just like our brain. Second, tools basically give agents the ability to interact with the outside world. And third is the agent loop allows the system to reason, act, observe, and continue working toward a goal. So if you remember only one sentence from today's video, remember this, that like generative AI generates an answer or any content, and agentic AI works toward a goal. So that is the foundation of agentic AI engineering. So in the next episode, what we will discuss. So in the next episode, means episode 2 of this agentic AI playlist, we are going one level deeper. What it is? Like we will answer the question like how does an AI agent actually work internally? So we will break down the goal, observations, reasoning, planning, tool selection, tool execution, observation, again replanning, final answer. So and most importantly, we will build a uh, like I can show you like how to build actually an agent from scratch before introducing frameworks. So if you are interested in agentic AI, LangChain, LangGraph, MCP, RAG, multi-agent systems, and enterprise AI architecture. So make sure like you follow the complete playlist. So this is code tab management, and I will see you in the episode 2, like how AI agents actually work. So don't forget to like, share, and subscribe. Okay, take care. Bye.